In my last video, I talked about motion in physics, but today I'm going to be solving some physics JAMB past question in motion, which I believe is going to be very, very beneficial, especially to those of you that want to write JAMB. So let's get into the business, guys. A boy accelerates uniformly from rest at 2 meters per second squared. Calculates his velocity after traveling 9 meters. So the first thing you want to do after seeing this kind of a question is to write out the parameters that you are given in the question. So it says a boy accelerates uniformly from rest. That tells you that our initial velocity equals to 0 at 2 meters per second squared. That's acceleration. 2 meters per second squared. So calculate his velocity, that's final velocity is unknown, after traveling 9 meters. So my distance is 9 meters. Now if you follow the last video I did, I told you that after writing out your parameters like this, then you select the equation that have the exact parameters, the exact values as given in the question. So if you don't follow up with that, you can just check my last video, you will see it there. So now the equation that has the exact parameters as we are given in this question is v squared equals to u squared plus 2ax. So the next thing I want to do now is for me to substitute these values for as I have it in this equation. So now I have my v to be unknown, then the u, which is the initial velocity, is 0 plus 2 times 2, which is for acceleration, times 9, which is for distance. So I have v squared equals to 0 plus 2 times 2 is 4 times 9. So I have v squared equals to 0 plus 4 times 9 is 36. So v squared equals to 0 plus 36 will give us 36. So what do? You square root both sides. So the square root of 36 is 6. So v equals to 6 meters per second. So this is a very, very sensitive kind of question under motion, which some students are very likely to miss it. Now it says a boy starts from rest and move with uniform acceleration of 6 meters per second squared. What distance does he cover in the third second? Now, when you see this kind of a question, the first place you are likely to miss it is this in the third second. In the third second does not mean that the distance equals to 3. Now, the third second simply means that the distance or the difference between the second and the third second. So that means that you will first find your distance covered for the second and for the third second, then you will find the difference. Now look at how I will do it. It said a boy starts from rest, initial velocity equals to 0, and move with uniform acceleration of 6 meters per second squared. Acceleration is 6 meters per second squared. So he said, what distance does he cover in the third second? So distance is unknown, but time will be 2 seconds. Now, which formula are we going to use for this? Which of the equation are we going to use? So it's going to be x equals to ut plus half at squared. So now we have our x to be unknown. U is 0 times t is 2 plus half times a, which is 6, times t squared, which is 2 squared. So I have x equals to 0 plus 3 times 4. 3 times 4 is 12. So x equals to 0 plus 12 will give you 12 meters. So that's the first one. Now the second thing you have to do now is that you have to calculate for the second. Now, having it in mind now that we have calculated our second to be 12 meters, the next thing you want to do now is to calculate for the third second. Alright, so now let's keep that here. S equals to 12 meters for our second, that's t equals to 2. So now let's calculate for the third second where t equals to 3. So we are still going to use the same formula, which is s equals to ut plus half at squared. But this time we are calculating for the third second. So now s equals to 0 times our t is 3 plus half times 6 times 3 squared. So I have x equals to 0 times 3 is 0 plus half of 6 times 9. So x now equals to 0 plus 3 times 9. So x equals to 27 meters. Now, the last step in this question now is to look for the difference between this 27 and 12. So that means that our distance covered for the third second now is going to be 27 minus 12. And that will give you what? That will give you 15 meters. I think you get that. So now every time you see this kind of a question, don't make the mistake of saying that your time equals to your t equals to 2 and eventually you get 12. If you stop there, you will see an option that is related to that in your question, but you will still miss it. The wisdom is that you will calculate for the previous second, which we calculated to be 12, then you calculate for that second, which is the third second in this case, then you will look for the difference between that previous second and this particular second. Alright, this is another example of a question related to the first one I've solved. Let's look at this together. It said a car accelerates uniformly from rest. Now my initial velocity equals to 0 at 4 meters per second squared. So acceleration equals to 4 meters per second squared. Then how far does it travel in the fifth second? So now what do? I will calculate for the fourth second. Now they ask for the fifth second. I will calculate for the fourth second and calculate for the fifth second. Then I will look for the difference. So that means that my t now is 4 and my distance is unknown. So now I'm going to use the formula that says x equals to ut plus half at squared. Now my x is unknown. U is 0 times t times 4 plus half times my a is 4, then my t is 4. So I have x equals to 0 plus half times 4 times 4 squared is 16. So I have x equals to 0 plus half of 4 is 2 times 16. So x equals to 32 meters. Now this is for the previous second because they asked us to calculate for the fifth second. So this is for the previous second, which is for the fourth second. So now we now go ahead and calculate for the fifth second. So remember that for the fourth second, which is the previous second before the fifth second, our x equals to 32. Let's keep that here. X equals to 32. Okay, so now let's calculate for the fifth second. So that means for the fifth second now, we have s equals to ut plus half at squared. So now I have my s equals to 0 times 5 plus half times 4 times 5 squared. So I have x equals to 0 plus half of 4 is 2 times 25. So I have x equals to 50 meter. Now, what's the next step now, which is the last step, is to subtract this 32 from this 50 so that we can get the distance covered for our fifth second. X now, which is x feet, will be equals to 50 minus 32. And that will give us what? So that's about that.